Hello, so now you know how to complete the square in one variable, and what we are going to do now is a kind of a variant on this. We will complete the square in several variables, but one variable at a time. So it's actually the same method, but repeated 2 or 3 times. Let's start. Completing the square in one variable at a time. And this is what we did in the previous video. We completed the square in one variable. And now we will see situations like this. So you see, here you have an expression. In this case, it's an expression in 3 variables, x, y, and z. And those a1, a2, and b1, b2, and so on, these are just numbers, just some constants. But you see that we have a part, as we had before, for x variable, for y variable, and for z variable, and then some constant term. So what we are going to do is exactly the same as we did for one variable, but we will do this for x, for y, and for z, one variable at a time. We will apply exactly the same method, but for each variable separately, because you see, these variables are not interconnected. There is no term which is called mixed term, like x times y or x times z. And of course, you also could have just 2 variables, just x and y. And here is our problem. We have to complete the square in 2 following cases. In the first case, you see we have 2 variables, x and y, and in the second case, we have 3 variables. Okay, so we start. What we are going to do is simply separate the variables. So first I will take the variable x. Where do I have x? Here and here. So I write x squared minus 2x, and by now you know that if I just add 1, I will have a complete square. You know this, right? And of course I have to subtract 1 to be good, to not to violate my equality sign. And now I proceed to variable y. I have y here and here. So I write y squared plus 4y, and now you see we have 4y, which is 2 times 2y. So this second term must be 2. So I have to add 2 squared, which is 4, in order to complete this square. And of course, to be good, I have to subtract this 4 at once. So here I will maybe mark these 2 zero operations to make it clear that you always have to correct for something you have added or subtracted. Okay, and what do I have in my expression? I still have plus 4. So I have to write here plus 4. And now my equality sign is perfectly happy, because the expression at the left-hand side is the same as the expression at the right-hand side. Okay, so I can continue, and now I simply write everything what I have here in this first parenthesis as a complete square. It is x minus 1 all squared. Then I proceed to the y variable. Here, everything here in this parenthesis is also a perfect square. So I add y plus 2 all squared, and now I have to gather my constants. So where do I have my constants which are not connected to some perfect square? I have minus 1, I have minus 4, and I have plus 4. So you see, minus 4 and plus 4 will just cancel out, so these 2 disappear, and I have simply minus 1. So this is well, I'm done completing the square. Now I got this expression, x minus 1 all squared plus y plus 2 all squared and minus 1. So minus 1 is just this constant behind my 2 perfect squares. Okay, so now I can proceed to the second problem. And I do exactly the same as I did before, but now I have 3 variables. So I start with x, and I write here that it will be x squared minus 4x, and you know by now that I have to add 4 in order to produce a perfect square. So here is my first perfect square, and of course I have to subtract this 4 which I have added. Then I proceed to my next variable, which is y. I have here y squared minus 6y. So then I write y squared minus 6y. And 6 is 2 times 3. So I understand that I have to add 3 squared, which is 9. And then, of course, I have to subtract this 9. And it's better to write really 9 when I mean 9. So here is the 0 operation, nothing happened. And I need a third color because I have one more variable. Here you see that I have minus sign, so I have to be careful here. And what I will do is the following. I will factor out minus 1 in order to get z squared with plus sign. So I write here z squared. And now you see here I have plus 2z, but because it will be in my parentheses with minus before, I have to write minus 2z. And I see that I can complete this square by adding 1. And you see it looks like I have added 1. But because of this minus here, I have actually subtracted 1. So I have to, in order to compensate, I have to write here plus 1. It looks strange, but think about this minus sign here before the parentheses. I have actually subtracted 1, and this is why I have to add 1 in order to compensate here. Okay, and then I just have plus 12 here, which is coming from the original expression. Okay, and now I'm almost there. I have already grouped my perfect squares. Now I just have to write them as squares. So here I get x minus 2 all squared. What about y? For y, I have y minus 3 all squared, right? And the last one with z will be minus z minus 1 all squared, right? And now the only thing I have to do is to gather my constants. So where do I have the constants which are not joined in any square? Here I have minus 4, minus 9, plus 1, and plus 12. And how much is it? How much is it? Minus 4 minus 9 is minus 13, plus 1 is minus 12, plus 12 is 0. So it's just plus 0. So I don't even have to write it. This means that my expression is equal to this expression here. I have just completed the square in 3 variables, 1 variable at a time. And just some words about applications. You see, you recognize here the left-hand side of this equation as the expression in part A in our problem. And you see, after completing the square, we got this form of equation. And from this equation, I hope that you can recognize a circle centered in the point 1 minus 2 and with radius 1. And the second case, in which we completed the square on this expression and we got this result, this equation with our expression as the left-hand side and with right-hand side 0 describes a double cone with a vertex in point 2, 3, 1. And more about this type of problems can be found in this course Calculus 3, Part 1 of 2, and here you have examples of some lectures and problems which are solved with help of completing the square. And here, surfaces. Thank you for watching. Bye-bye.